In this episode, we dive into the key concept that powers Bob's ability to answer questions in a smart, flexible way: text embeddings. This is the hidden mechanism that lets Bob recognize that "how do you speak" means the same thing as "how do you talk," even though the words are different. Text embeddings are a way of converting text, words, phrases, sentences into numbers, specifically into vectors or arrays of numbers. These numbers represent the meaning of the text in a high-dimensional space. You can think of them like coordinates that place text somewhere in a conceptual landscape. 3 numbers equals 3D space, which is easy to visualize. 384 numbers equals 384-dimensional space, which is hard to visualize but more expressive. There are older methods like bag of words which can operate efficiently with far fewer dimensions, but they ignore word order. So, the dog chased the cat is the same as the cat chased the dog. But Bob uses AI-based embeddings because they preserve meaning and context, which matters when someone says, "How do you speak?" instead of "How do you talk?" The magic is that similar meanings are mapped to nearby locations, even if the wording is completely different. Bob uses a method called cosine similarity to compare these vectors. Instead of comparing exact words, cosine similarity compares the direction of vectors. In other words, how aligned they are. A similarity of 1.0 equals identical direction, i.e. very similar meaning. A similarity of 0.0 equals completely unrelated. For example, the FAQ entry is "How do you talk?" The user types in "How do you speak?" Bob detects high similarity of 0.978 and gives the same response. If no FAQ entries match above a certain similarity threshold, Bob returns a fallback like, "That question is a little outside what I know." This is where most tutorials fall short. They don't tell you what to expect from real-world embeddings. Words that feel very different can be close in embedding space due to shared context. Winter and summer may seem opposite. But in the world of all words, they are both seasons, tied to weather, temperature, time, holidays, school, etc., which means rich embedding overlap, so they often end up close together. What this means for you, if you dig into the code or develop your own system. You'll want to start with a high threshold, e.g. 0.9, and lower only if needed. Manual testing is essential. Review what your model returns to different user inputs. Sometimes the best fix is just adding a new FAQ entry rather than tweaking thresholds. This is all handled automatically in the Building Bob library, but knowing it helps you adjust the system if needed. Bob supports 2 types of knowledge: shared knowledge, which all characters can access, and character knowledge, where each character, like Bob, can have their own unique knowledge. For now, we're just using Bob's personal FAQ. The embedding model is loaded at startup along with Bob's FAQ. An object containing the location of the FAQ, whether the data has a header row and a reference name, are required. The info key will be covered in the next episode, but it is commented in the code for now. The callback is the function to call once the data is loaded and embedded behind the scenes. The object is passed to the add character knowledge. The knowledge is embedded behind the scenes, and the appropriate callback functions are called once complete. Bob's FAQ is relatively small since this is an example of what can be done. Crafting the answers in a particular style helps to give the character some personality. ChatGPT was used to stylize the responses in a consistent way. Changing the nature of the responses would change the perceived personality of the character. We will get into more depth on personality in later episodes. The first row here is the header, which is why the object contained header, true. As you can see, there are actually 3 columns in the data: question, answer, and category. Category is not currently used, but it is included for future expansion, if and when a much larger FAQ is used. The category can then be used to reduce the set of options tested by first determining the question category. Building the model for this may be a future addition as the library is built out. Entry 25 is the How Do You Talk example used earlier. As you can see, the preset response is, I use your browser's built-in text-to-speech TTS or a TTS model called Kokoro, running right in your browser. If we ask Bob, how do you talk, or how do you speak, we can see that he provides the same answer. If you want to change the FAQ that Bob is using, select the knowledge icon under Bob's avatar. Then select the Replace FAQ icon near the top of the dialog box. You can then select a CSV file for Bob to use for his responses. Bob will now respond accordingly. An in-depth chatbot could be built using this method alone, rivaling the choice-based bots still used by many large companies. Such a system would feel much more natural to the user. Massive categorized FAQ equals natural dialogue coverage. No generation equals no hallucination risk. Works locally, fast, and securely. Easy to audit and expand. Can simulate memory or emotion by swapping FAQ sets. An FAQ-only system might start with a large FAQ with categories, or a number of small FAQ files grouped by category. The Building Bob system computes the FAQ question embeddings on page load. This may not be practical with a large FAQ system. However, you could pre-compute and load embeddings versus computing at runtime. In order to minimize storage requirements, you can limit the number of digits saved for the embeddings. This feature is built into the Building Bob library and can reduce the embedding storage size to a third compared to allowing the full number of digits. This efficiency tip has very minimal impact on similarity comparisons. When the user inputs their query, we would now have two steps to complete. The user input would be passed through a multi-layer perceptron classifier to determine the appropriate comparison category. The user input would still be embedded as before, but it would only be compared for similarity to questions in the same topic category. The resulting answer would be output as before, or if no strong match is found, the model would return a response such as, that question is a little outside what I know. Bob is already designed to return the top K matches, even though he currently just uses the best one. This opens up possibilities like letting users choose the best match from multiple options and tracking selections to improve the FAQ over time. That's a nice improvement path for an FAQ-only system. Next episode, we go deeper by adding a mini RAG system for Bob. We'll cover loading longer text files for Bob to learn from, using embeddings to retrieve relevant passages. The basic idea of retrieval augmented generation, or RAG, but simplified for local use.